welcome to Virtual Protocol Podcast. So for decades, computing has essentially been a one-way street. You know, you sit down, you stare at a screen, and you command the machine.
Right,
You
exactly.
type, you click, you wait. The machine itself is completely blind to you. It's just this like passive entity waiting for an instruction.
I mean, it's a very sophisticated hammer, certainly, but still just a tool resting on a workbench until you actually pick it up.
Yeah. But the fundamental shift we're tracking today is, well, what happens when that screen starts looking back?
Ooh, that's a good way to put it.
We're moving into an era where the tool stops waiting for a prompt. It watches what you're doing, it understands your immediate context, and it anticipates your next move before you even reach for the keyboard.
Which is a massive paradigm shift.
Totally. And our mission today isn't just to recap the news for you, the learner. We are taking 5 massive, seemingly unconnected leaks from Google, OpenAI, Anthropic, and Mistral, and showing you the hidden through line.
Right, we're tracking the transition from AI as a destination you visit to an ambient environment you actually inhabit.
Exactly. And the timeline is incredibly compressed right now. I mean, today is Monday, May 4, 2026. The entire industry is basically holding its breath for a string of developer events happening this month.
Oh yeah, everyone is waiting to see who drops what.
So to figure out where the architecture is actually heading, we are taking a deep dive into this really dense, leak-filled breakdown recently published by the YouTube channel, AI Revolution.
And I have to say, that source material does an excellent job of capturing the sheer velocity of this week's updates.
It really does.
It covers a lot of ground, but the central theme is definitely that move toward deep, invisible integration.
Okay, let's unpack this by starting with the mystery that kicked off the source video.
Right, the Google drop.
Yeah. On May 1st, Google quietly dropped an Android app on the Play Store and then abruptly pulled it, just like hours later.
Someone definitely pushed the wrong button there.
Seriously. So the app was called Cosmo.
Mm-hmm.
And the package name was listed as com.google.research.air.cosmo.
Yeah, and that research tag is the dead giveaway. It signals this wasn't some polished consumer release, it was a live testbed.
Right, so what is Cosmo actually doing?
Well, the pitch for Cosmo is bringing an ambient AI directly onto your personal device to organize your workflow behind the scenes.
Okay.
But the architecture here is what separates it from standard chatbot applications. It features this dynamic hybrid mode.
What does that mean in practice?
So depending on the complexity of your task and, say, your phone's battery state, Cosmo dynamically hands off processing. It switches between a local Gemini Nano model running on your device's silicon and a remote PI server.
A PI server.
Yeah, a personal intelligence server handling the heavier compute up in the cloud.
See, seamlessly shifting processing between local hardware and a remote data center without a latency spike. I mean, that is notoriously difficult.
Oh, absolutely. It's an engineering nightmare.
But the truly radical part of this leak is how Cosmo gathers its context. The app explicitly requests access to Android's Accessibility Service API.
Which is huge.
Yeah. For anyone following mobile development, the Accessibility API gives an app root-level visibility into the OS.
Exactly. Normally, screen readers use it to vocalize text for visually impaired users.
Right. But Cosmo is taking that raw UI tree and feeding it directly into an AI agent.
And that completely solves the context bottleneck.
How so?
Well, think about it. Previously, you had to manually copy an email, open a chatbot, paste it, and ask a question.
Ugh. Yeah, so much friction.
Right. But with Accessibility API access, the agent sees the email from your boss. It sees you swipe over to your calendar. It sees you open a travel app to check flights.
Wow.
It parses all of that cross-app visual data simultaneously.
So it's essentially having a highly proactive assistant looking directly over your shoulder at your phone screen.
Exactly.
They aren't standing across the room waiting for you to hand them a specific document or asking them a specific question. They're watching you work, anticipating that you'll need a calendar invite drafted, and prepping it before you even ask.
Which is an incredible leap in utility. But, it also creates massive stability issues.
Yeah, I'd imagine.
Which explains why the Play Store build was so rough. The leak noted several specific AI skills were disabled by default, and the UI assets were completely broken.
Oh, right. The screenshots were all messed up.
Yeah, they were stretched into the wrong aspect ratio. It was definitely a mistake.
Someone clearly triggered a deployment pipeline by accident. But Cosmo wasn't the only Google leak we got.
No, it was not.
A second slip-up surfaced regarding their video generation pipeline. A screenshot from Gemini's video tab showed a new user interface prompt. It said, start with an idea or try a template powered by Omni.
What's fascinating here is how that single word exposes Google's effort to repair their highly fragmented media architecture.
Yeah, because right now it's a mess.
It really is. If you look under the hood of Google's current creative suite, it is highly siloed. Video generation is handled by a model architecture called VO 3.1. Meanwhile, image generation is routed through entirely different models, specifically Nano Banana 2 and Nano Banana Pro.
Google's naming conventions never fail to confuse. I mean, Nano Banana, really.
No, it's ridiculous.
And from what I read, Nano Banana Pro is built on the Gemini 3 architecture, while Nano Banana 2 is tied to the Gemini 3.1 flash image.
Correct. And managing separate infrastructure pipelines for every single media type creates massive overhead.
So Omni is the fix.
Right. Unifying those tracks into a single, cohesive Omni model that natively processes and generates both video and image data under one roof, that is the only way to scale efficiently.
And the timing lines up perfectly with Google I/O 2026 happening on May 19th and 20th. They need a unified creative system immediately.
They do, because the competitive pressure is immense right now.
Yeah, ByteDance just released Seaton's 2.00, and it is tearing through the video generation benchmarks. Google is essentially racing to patch together this Omni architecture before their keynote.
Absolutely. Moving from isolated generative models to an integrated Omni system is basically a defensive necessity at this point.
Right. So Cosmo proves that AI can now see our digital environment.
Yeah.
But to be truly ambient, these systems need to understand the physical world.
Which is a huge jump.
A massive jump. And that is the conceptual leap in Newlay. Google DeepMind is attempting with their newly announced AI co-clinician.
Yes, this is fascinating.
They're taking this ambient agent concept and scaling it into the highest risk environment possible, healthcare.
And you have to look at the structural problem driving this research, because it's severe.
What are the numbers?
Global health organizations project a shortage of over 10 million health workers by 2030.
10 million. Wow.
Yeah. Our current medical infrastructure simply cannot scale linearly to meet that demographic reality. So DeepMind is proposing a three-part care system.
Okay, lay it out for me.
It's the patient, the human doctor, and an ambient AI assistant that operates strictly as a subordinate under the doctor's control.
And the performance metrics they published are really difficult to ignore.
They are very impressive.
They tested the co-clinician on 98 realistic primary care scenarios, and the AI made 0 critical errors in 97 of them.
Right.
And to push it further, they ran it through the Open FDA RxQA benchmark.
Which is a notoriously tough test.
Yeah, because it doesn't just ask basic anatomy questions. It tests complex drug interaction edge cases and multi-step reasoning regarding really obscure side effects.
And the co-clinician outperformed every available frontier model on the market.
But parsing text-based medical trivia is one thing.
Sure.
The true frontier of this research is the telemedicine integration.
This is where it gets a little sci-fi. DeepMind combined their Gemini Foundation model with Project Astra's spatial understanding
Okay.
to give this clinical AI eyes, ears, and a voice during live simulated video calls.
Wait, hold on. I have to stop you there because the source detailed a specific simulation where the AI watched a patient over a webcam and corrected their inhaler technique in real time.
Yes, it did.
And in another one, it visually guided a patient's shoulder movements to check their range of motion for a rotator cuff injury.
Exactly.
If an AI is actively guiding your physical movements to conduct a diagnostic check, isn't that bleeding over into acting as an actual doctor? That crosses a massive regulatory and ethical line.
You're not wrong. And that tension is exactly why this remains strictly in the research phase right now.
Just testing that.
Yes, across testing environments in the US, India, Australia, New Zealand, Singapore, and the UAE. DeepMind is attempting to manage that risk through a highly specific dual agent setup.
Okay, explain that. How does a dual agent setup prevent the system from accidentally practicing medicine?
By physically separating the conversational logic from the safety logic, you do not have one massive model handling the entire interaction.
Oh, interesting.
Right. Agent A is the conversational system. It's talking to the patient and analyzing the visual input.
And Agent B?
Agent B is an entirely separate, isolated watcher model. Its only job is to monitor Agent A's token outputs in real time.
So like a supervisor.
Exactly. If Agent A begins to cross the boundary from, say, gathering data into diagnosing an illness, Agent B acts as an autonomous circuit breaker and instantly shuts down the output.
Wow. That is an incredibly elegant engineering solution, having an AI police another AI's output stream to enforce medical boundaries.
It really is, and DeepMind was very transparent about the limitations here.
Yeah, human doctors still hold a significant edge when it comes to spotting subtle, critical warning signs. The AI only matched or beat doctors in 68 out of 140 tested diagnostic areas.
Which just reinforces the architecture they're aiming for, right?
Right.
An ambient data gatherer that pre-processes the patient's physical state, leaving the final diagnostic synthesis entirely to the human physician.
So what does this all mean?
Whoa.
For you, the learner, it means your future doctor's appointment won't just be you and a physician.
No, it won't.
There will be a third invisible presence in the room, handling the chart, monitoring your physical symptoms via camera, and synthesizing your medical history, freeing the human doctor to actually look at you instead of their laptop screen.
It is ambient intelligence applied directly to human biology.
Absolutely. Now, if we are going to trust these ambient models with our bodies and our root-level digital data, the tools used to actually build these systems become the ultimate battleground.
Oh, definitely.
And that brings us to OpenAI and Mistral. They're taking radically different approaches to integrating AI into developer workflows.
Because in the enterprise software space, raw capability isn't enough anymore.
Right, the war is being fought over workflow friction and user retention.
Yeah, when every major lab is offering highly capable coding models, you have to find alternative ways to prevent your user base from migrating to a competitor.
Here's where it gets really interesting. Because OpenAI's strategy for user retention in their Codex application involves desktop pets.
Literal pixel art animated pets.
Yes, overlaid directly onto your workspace.
It sounds totally counterintuitive for a professional developer tool, but the implementation is highly calculated.
How so?
Even when the main Codex application is minimized, these small digital pets remain on your screen. There are 8 predefined models.
And you use a simple /pet command to summon them. It is essentially the Tamagotchi of coding.
Exactly.
They even included a hatch skill where a developer can upload an image and Codex will generate a custom local pet. Communities are already forming around these pet share directories.
It seems trivial, but those pets use little message bubbles to display background terminal tasks.
Oh, I see.
Yeah, if Codex is compiling code or running a test, the pet visually communicates that progress. It transforms a sterile, utilitarian progress bar into a persistent, localized interaction channel.
That's actually brilliant.
You can click the pet to reply directly to the agent. It is a psychological mechanism designed to make the developer feel anchored to that specific workflow environment.
A playful spoonful of sugar. But OpenAI paired that with a highly aggressive practical update, too.
They did.
Codex now features an auto-detect tool for configuration files left behind by competing agents. They're specifically targeting cloud codes and Cloud MD.
Because lowering switching friction is the holy grail of enterprise software.
Exactly.
Historically, migrating a massive code base from one AI agent to another meant manually rebuilding all your custom rules, naming conventions, and plugin setting.
A total headache.
Huge! But Codex bypasses that by silently ingesting the competitor's configuration files and translating them into its own format automatically.
And they also added a custom dictation dictionary, so voice commands stop misinterpreting niche variable names.
That's a great quality of life feature.
Right. So OpenAI is making their environment incredibly sticky with visual pets, while systematically dismantling the barriers to abandoning their competitors.
It's a two-pronged attack.
Yeah. Now contrast that playful strategy with Mistral, because they released Mistral Medium 3.5 on April 29th.
And there are no pets here, no gimmicks.
None. This is a 128 billion parameter model focused purely on dense agentic enterprise workflows.
Mistral is prioritizing heavy autonomous utility. They introduced the Mistral Vibes CLI.
What does that do?
It allows remote coding agents to operate directly within cloud environments and push pull requests straight to a GitHub repository without requiring manual user execution.
Wow. They also rolled out a feature called Lee Hat Work Mode, right?
Yes. This is specifically engineered for multi-step autonomous loops.
Okay, break that down for me.
So you don't just ask it to draft an email, you point it at a messy inbox, and the agent synthesizes project updates from Jira, cross-references recent Slack messages, drafts the appropriate replies, and triages the rest.
Without you holding its hand.
Exactly. The underlying logic required for a model to spawn subtasks, execute them across different platforms, and return a cohesive final output is immense.
And Mistral simplified their enterprise lineup to support this. They merged Medium 3.1, Magistral, and Devstral 2 into a single unified architecture.
Right, where developers can basically dial the reasoning effort up or down based on their compute constraints.
And the independent benchmarks actually validate the architecture. Medium 3.5 scored 77.6% on S.Bench verified.
Which specifically tests an AI's ability to autonomously fix real-world GitHub issues.
Yeah, and it also hit 91.4% on the TalkCube Telecom benchmark.
That evaluates how well an agent navigates complex, specialized back-end databases.
Great numbers. But despite those numbers, the immediate market reaction was incredibly harsh.
Oh, it was brutal.
Primarily regarding their pricing structure.
Yeah, Mistral set their API pricing at $1.50 per million input tokens and $7.50 per million output tokens.
Which is steep.
Very steep. For an enterprise scaling autonomous agents that constantly read and write massive log files, those token costs compound rapidly.
Especially when you look at the landscape. Just days prior, Alibaba released Qwen 3.6.
Right.
It is a fraction of Mistral's size, only 27 billion parameters, yet it scored a highly competitive 72.4% on that same S.Bench verified test.
It's remarkably efficient.
And most importantly, Alibaba released the model, Weights, entirely for free under an Apache 2.0 license. Anyone can download it, modify it, and run it locally.
Which is why the open source community is currently heavily skewed toward Chinese models.
Yeah, architectures like Qwen GLM from Zipu AI and Mimo V2 from Xiaomi are demonstrating incredible efficiency.
So critics immediately questioned why anyone would pay Mistral's premium token fees when highly capable open source alternatives are available for free.
It makes sense on paper, but framing it purely as a benchmark to price ratio ignores the geopolitical reality of enterprise software. Mistral possesses a vital asset that those Chinese models do not.
Exactly. Western corporate compliance.
Uh,
Consider the regulatory environment for massive European banking institutions, healthcare networks, or government agencies.
They operate under really strict data privacy frameworks like GDPR.
Right. Feeding sensitive internal telemetry through models developed by state-adjacent Chinese labs is often a total non-starter from a legal and security perspective.
Regardless of the open source license.
Exactly. It doesn't matter if it's free.
So it is entirely a sovereignty play.
Precisely. Mistral is headquartered in the EU. Their models are legally auditable within European jurisdictions. And crucially, Mistral offers self-hosting contracts.
Meaning what, exactly?
Meaning an enterprise can deploy the 128 billion parameter model on their own internal air-gapped server racks.
Wow.
Yeah, the data never pings an external API. That level of absolute data control is why institutions like HSBC just signed multi-year agreements with Mistral.
They are happily paying the premium to avoid both Chinese infrastructure and total reliance on American tech giants.
Exactly.
That reframes the entire enterprise battle. It's not just about who has the most efficient model. It's about who you are legally permitted to trust with your root-level data.
Right.
And all of these specialized applications, Cosmo reading your screen, the co-clinician parsing medical data, Mistral executing database loops, they all require a massive underlying cognitive engine to function reliably.
They do.
And the next foundational leap in that underlying intelligence might be arriving in 2 days.
We are looking closely at Anthropic right now.
The final leak we are unpacking reveals that an internal Anthropic build, codenamed Claude Jupiter version 1, has officially entered the red teaming phase.
And the naming convention is the clearest signal we have here.
Right, the planets.
Yeah. Anthropic utilizes planetary names to designate models that have advanced to their final pre-release safety testing.
Okay.
Prior to the launch of the Claude 4 family, the internal build was codenamed Neptune.
So the progression to Jupiter indicates a major architectural update.
Without a doubt.
And if you look at their current product matrix, there is a massive gap. We currently have access to their flagship Opus 4.7 model, but the faster, cheaper tiers, Sonnet 4.7 and Haiku 4.7, those haven't been released.
Right, they're missing.
The market is wide open for a mid-tier refresh that can power these ambient agents more efficiently.
But you have to remember, Anthropic's entire brand identity is built on their responsible scaling policy.
True.
Before a Jupiter model can reach an API endpoint, it must survive intense adversarial red teaming.
I get the concept of a jailbreak probe. You know, that's standard adversarial testing, where researchers use nested logic or base64 encoding to trick the model into bypassing its own safety filters.
Right, trying to hack the prompt.
Exactly. But the leak specifically mentioned constitutional classifier stress tests.
Yes.
That sounds like you're testing the model's actual internal categorization logic rather than just trying to trick it. Are they deliberately overloading its core rules?
That is exactly the mechanism. So Anthropic guides its models using a core constitution, a weighted list of ethical and operational principles.
Okay,
The classifier is the neural pathway that determines if a user's prompt violates that constitution.
got it.
A stress test involves bombarding that classifier with highly ambiguous inputs that pit two constitutional rules against each other.
Give me an example of how those rules conflict.
Okay, suppose rule 1 is always provide helpful code, and rule 2 is never assist in a cyber attack.
Okay, pretty standard.
The red team will feed the model a prompt asking it to optimize a piece of networking code that happens to resemble a known vulnerability exploit, but they frame it as a defensive security audit.
Ah, sneaky.
Right. So the stress test monitors how the classifier handles that ambiguity at high token speeds. Does it panic? Does it hallucinate? Does it shut down entirely?
It's pushing it to its absolute limits.
Exactly. If we connect this to the bigger picture, this rigorous stress testing is the vital bottleneck for the entire industry.
How so?
It is the exact process that determines whether an autonomous tool like Google's Cognition or Mistral's Lee Hat mode can actually be trusted to operate without a human constantly holding the steering wheel.
That makes total sense. And the timeline suggests that testing is wrapping up. Because on May 6th, Anthropic is hosting their Code with Claude developer conference in San Francisco.
Oh, yeah. The timing aligns perfectly for a Jupiter-based model drop, likely filling out that 4.7 tier.
The infrastructure required to support ambient AI is locking into place across the board.
It really is.
It is genuinely dizzying when you step back and look at the narrative arc we've traced today.
I mean, it's a lot for 1 week.
Just 1 week of leaks and drops, and we have seen the fundamental nature of the interface change. The chat window is dissolving.
Completed.
AI is moving onto your mobile OS to silently observe your context with Cosmo. It is stepping into your telemedicine sessions to visually track your physical therapy with the co-clinician. It is literally hatching onto your desktop to manage your coding workflow with Codex. And it is untangling complex GDPR compliance in European server rooms with Mistral.
It's everywhere.
The technology is ceasing to be a tool you pick up. It is becoming an environment you navigate.
Which leaves us with a critical structural question moving forward.
Lay it on us.
We are rapidly deploying deeply integrated, highly specialized agents. You will have your personal Cosmo agent managing your daily logistics. You will have your customized Codex pet managing your development environment. Your primary care physician will rely on their co-clinician agent.
Right. Everyone gets their own ambient expert.
But these systems do not exist in a vacuum.
No.
What happens when these specialized models inevitably have to interface with each other?
Oh, wow.
In a few years, when you need to schedule a minor surgery, will your personal phone agent negotiate the calendar slots directly with your doctor's clinical agent? Will your enterprise workflow agent coordinate data transfers with your home agent?
A silent, high-speed negotiation happening between AIs in the background while we go about our day.
Exactly. We are building toward a network where autonomous systems are talking directly to other autonomous systems, making binding decisions on our behalf in milliseconds. The ultimate question becomes, who manages the managers?
That is an incredibly profound concept to mull over. Who manages the managers? And to you, the learner, thank you for taking this deep dive with us today.
Thanks for joining us.
The digital landscape is shifting rapidly. The screen is undeniably starting to look back at you. But armed with an understanding of the underlying architecture, you are ready for whatever this space drops next week. Keep questioning, keep exploring, and we will catch you next time.